Okay, good morning everybody. This is Mrs. Van Torn, and I want to talk to you about section 8.1 on the Pythagorean Theorem and its converse. So we've already taken notes in our theorem book, so I just want to remind you what the Pythagorean Theorem is. It states that a squared plus b squared is equal to c squared, and this is a great theorem, but you have to know what it applies for and what it's used for. So first of all, when is it used? In right triangles. That's when it's used, in right triangles, and when you're trying to find one side. When one side is missing. So it doesn't really matter which side. I just know I have to have a right triangle. So let's make sure we have a right triangle. And this is the most important thing. This really is the most important thing. This letter C represents the hypotenuse, which happens to be the longest side. We'll always know which one is the hypotenuse because when you follow this arrow, this fill in the box, it always points to the hypotenuse. So that must be the letter C, and it does not matter where the legs go. So this is A and this is B. So remember, this is the leg, and this is the hypotenuse. All right, some very, very, very famous numbers. They're called the Pythagorean triples. And these are numbers that make the Pythagorean theorem work. So these are whole numbers that make the Pythagorean theorem work. It makes a squared plus b squared equals c squared true. So as long as a squared plus b squared equals c squared is true, and they're whole numbers, got my number symbol. These are whole numbers that make the Pythagorean theorem come true. So for an example, 5 would have to be the longest side. That would be my C. So just to check, I have 5 squared. I'm going to do a squared plus b squared equals c squared. So 3 squared plus 4 squared, does it equal 5 squared? 9 plus 16 equals 25. 25 equals 25. So this is a check. The beautiful thing about any of these is any multiples of these always work. Multiples of these also work. I can't spell multiples anymore. Multiples of these triples work. If you can memorize these multiples, you can always know you have right triangles. What I mean is, multiply these numbers by 2. 10, 12 times 2 is 24, 13 times 2 is 26. This is also a Pythagorean triple. Multiply 3, 4, 5 times 3. 3 times 3, 9. 4 times 3, 12. 5 times 3, 15. This is also a Pythagorean triple. Any multiples of these numbers also work. Okay, let's do a couple of examples to show you how we're going to be using this. A right triangle has legs of 16 and 30. So this is a word problem. Anytime you have word problems, draw pictures. So draw pictures of the words. This is huge. You have to understand what you're dealing with. So I have a right triangle. So I'm going to draw the right triangle. Legs of 16 and 30. So these are my legs, 16 and 30. Find what? Find the length of the hypotenuse. This is my unknown, so I give that my x. So we're going to actually find the length of the hypotenuse, and we're going to use Pythagorean theorem to do so. Now, we have to make sure we know which one is our hypotenuse. Point to it, that's the C. Here's my A, here's my B. So using a squared plus b squared equals c squared, I'm going to put my numbers in. 16 squared plus 30 squared equals x squared. Okay, now here's the beautiful thing. You have a calculator that has a squaring button. You can type all of this in at once. So we're going to go ahead and type in 16 squared plus 30 squared. And my calculator tells me it's 1156. And now I'm going to use the square root button and take the square root of both sides. That's going to isolate my x. So my x is all by itself. So I get x equals, and I'm going to take the square root of 1156, and my answer is 34. And I'm done with the problem. Okay, the second part of this question says, do these lengths of the sides form a Pythagorean triple? So what were my sides? 16 and 30 and 34. I just want to show you that the answer to this question, of course, is yes, because they are whole numbers, and Pythagorean theorem does hold true. So this is yes, but I want to show you, this is amazing. Divide these each by 2. 8, 15, 17. Now look up at your Pythagorean triple list. This is a special Pythagorean triple. So when you take this and multiply it by 2, you get these numbers. So the answer is yes, it is a Pythagorean triple. Example 2, find the value of x. Leave your answer in simplest radical form. That means no square root buttons. All right, let's first of all, here's my right angle. Point to it. There's my C. I'm going to make this my A, make this my B. Using Pythagorean's theorem, x squared plus 10 squared equals 12 squared. This becomes an algebra problem. So we are going to isolate the x squared by minusing 10 squared from both sides using the subtraction property. Cancels those out. And I get x squared equals. Now here, be careful. This answer is not 2 squared. This is not the number 12 right here. That's 144 because it's 12 squared. This is not the number 10. It's 10 squared, which is 100. Use your calculator and type in 12 squared, take away 10 squared. You should get an answer of 44. Now take the square roots of each side. Simplest radical form. This is the square root of 4 times the square root of 11. This is my only perfect square, so my final answer is 2 square roots of 11 in simplest radical form. All right, a couple more examples to get through. Let me clear this ink. Next page. Example number 3. Notice this is a word problem, so we're going to draw a picture. To represent the words. A baseball diamond is a square with 90-foot sides. Okay, now we're going to make it like a baseball diamond. It's a square with 90-foot sides. So I got my right angles and I have my 90-foot sides. If you've never played baseball or softball, this is how it works. This is home base, first base, second base, and third base. And we call this home. Home plate and second base are opposite vertices of the square. How far is home plate from second base? I'm going to draw a line from home plate to second base. I want to know how far that distance is. So, folks, we are actually going to use half of the square because it forms a right triangle that I can use. Here's my right angle. This is my letter C. I'm going to make this A and make this B. So in A squared plus B squared equals C squared, I'm going to fill in what I know. 90 squared plus 90 squared equals x squared. I'm going to use my calculator. 90 squared plus 90 squared is equal to 16,200 square root, square root. Now read carefully. About. This word about means you can use your calculator and round to the nearest tenth of a decimal point. Round to 1 decimal point. So we're going to actually take the square root of this number. So the square root of 16,200, according to the calculator, is 127.279. Here's the cutoff. 1 decimal. What does a 7 do to the 2? It makes it move up to a 3. So x, I use squiggly equals to show the reader or show you I'm rounding my answer. That means it's been rounded about 127.3. My label in this problem is feet. Okay, the last thing we're going to talk about is how do you classify a triangle according to its angles. Is it a right triangle, obtuse triangle, or acute triangle? And the converse of the Pythagorean theorem will tell us this. Now, everything is based on the longest side. The longest side. Just want to remind you that. We're going to use the converse, so we're going to start with the C. Everything starts with the C, and we're going to compare it. If it's equal, if the longer side squared is equal, it's a right triangle. If it's bigger, then it's an obtuse triangle. And if it's smaller, then it's an acute triangle. So equal is right, bigger is obtuse, and acute is smaller. So let's give an example. First of all, which one is the biggest side? The 7. This is my C. We're going to make this A. We're going to make this B. We're going to check, does C squared equal A squared plus B squared? That's all I need to know. We're using the converse. I'm going to flip-flop the Pythagorean theorem. I'm going to put my numbers in. Does 7 squared equal 4 squared plus 6 squared? Okay, we're going to use the calculators. 7 squared, I know, is 49. And then you type in all of this at once. So I'm going to type in 4 squared plus 6 squared, and I get 52. Now, the answer clearly is no, it's not a right triangle. I can see they're not equal. As a matter of fact, this number is smaller. So, no, it is an acute triangle. It's not a right triangle because Pythagorean's theorem does not work. The C squared is smaller. Okay, we're going to do a couple more examples, and then you're going to do your own homework. Okay, 2 more examples. Again, this is the letter C because it's the biggest side. So we're going to make this A and make this B. So the question is, does C squared equal A squared plus B squared? Does 25 squared equal 15 squared plus 20 squared? Let's check. 25 squared is 625. When I use my calculator, type in 15 squared plus 20 squared. This whole thing also equals 625. They're equal. This means it is a right triangle. By the way, going back to those Pythagorean triples, take a look at all three of these numbers. Divisibility rule so they can be divided by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. 25 divided by 5 is 5. This is a 3, 4, 5 right triangle. I could have said it's a 3, 4, 5 without doing any of this work and known it was a right triangle. So this is a 3, 4, 5 triple times 5. So yes, it must be a right triangle. All right, one more. Let's just take a look. I'm going to make this my A, my B, my longest side is C. We're going to check, does C squared equal A squared plus B squared? That's the question. Does 20 squared equal 10 squared plus 15 squared? Let's find out. 20 squared is 400. 10 squared plus 15 squared is equal to 325. They definitely are not equal. As a matter of fact, this number is bigger. Therefore, it is an obtuse triangle. All right, you guys are able to do your own homework. Section 8.1 is on page 420, numbers 1 through 29, the odds. You must show your work to justify each answer. So good luck. You have fun with Pythagorean Theorem. Bye now.